All right. Good evening, everybody. How's everybody doing? Somebody's more awake than I am. So welcome to React Denver. We'll just go over a couple things pretty quick. I'm pretty sure that everybody's found the pizza already. But if you haven't, please come get some pizza. Drinks at the end, salad on this end. Restrooms are in the hallway right behind us. There's some over by the elevators. There's also some immediately on the other side of this wall down a short hallway. Tonight we'd like to thank our sponsor, Exactly. We've got a number of people from Exactly here tonight. We'd also like to thank Turing for our venue and Salt Lending for covering our meetup fees. And as always, thanks to our individual sponsors on Open Collective as well. For anybody that doesn't know, you can, just as an individual contributor, donate money to the meetup to help cover costs, sponsor things, etc. We've had a number of people do that in the past, right when we kind of launched it. And that also makes the finances easier for when companies sponsor us. There's a thing for it to go through. It is, since it goes through their foundation, it is a nonprofit organization and donation, which makes it easier for companies as well. And then coming up in August, I think it's right before, yeah, that'll be the week before the August meetup, is Develop Denver. For anybody that hasn't been before, Develop Denver is an amazing local community event. Cross-platform, cross-discipline, front-end, back-end, infrastructure, design, product, kind of everything in development and related kind of things in Denver. You can still buy tickets at developdenver.org/discount tickets, and there's a discount code on here. I believe, don't quote me on this, I believe that takes it down to $150, or it might be down from $250 to $199. I don't remember. You'll find out what it does when you go to use it. Sorry about that. It's been a long week already. So, all right. So for anybody that's hiring, please feel free to come up and put jobs up here. I'm actually gonna, just since we got going a little late, I'll have people come up and kind of talk about positions in the intermission between the two talks. But yeah, if you're hiring for anything, feel free to kind of write something up here, and then yeah, just put kind of contact info or what company it's for. Sorry, David confused people by putting a company column, but they're sponsoring, so that's fine. So, but yeah, we'll circle back to that in a little bit here. My announcement slide was about Develop Denver. As always, we are looking for help with the meetup. We've got 3 organizers here tonight. One of them is upstairs letting people in. The other 2 are David and myself. We're always looking for help, open to help. You know, kind of shifts. Summertime, we've got less people here, so that's why we're kind of running around with our hair on fire. We're also always looking for speakers and sponsors for future events. So if you are interested in either of those things, feel free to come up and talk to David or I afterwards. There's info on our website as well, reactdenver.com. Yeah, and you know, it could be first time speaker. You want to, you know, kind of give your first talk. We'll happily help you kind of prep for that. You know, you could kind of use us as a like test run before a conference. We've had a number of those, so yeah, pretty much welcome to kind of anything. Usual talk format is like half hour-ish. You can do QA if you want. You don't have to. Q and A, rather. People are laughing at that. You can do QA if you want to. Yeah, and so, you know, you can have a more like code-focused talk where you're kind of walking through something. You could have more kind of slides where you're just talking on a topic. So, you know, pretty much we're open to a talk on anything that's tangentially related to React. So, all right. So first up, we have Mr. Chris Bolin from Formidable, and he's going to be talking to us about debugging, philosophies, and techniques. Bug emoji. Do you want the handheld or do you want a headset?
No, this is great. This is
Okay.
awesome. Thank you so much. Awesome. So I'm here to talk to you about debugging, both the philosophies of debugging and some of the techniques that I've used and I've seen other people use along the way. My name is Chris Bolin, and despite looking like a pretty cool youth pastor, I am I'm a software engineer like most of you. I work at a company called Formidable. We have a small office here in Denver. Well, it's bigger now, a little over 10 people. So Formidable, can you raise your hands? We didn't get everybody here, but we got some. So we help people build React applications, Node applications, GraphQL, use technologies like that, kind of in the JavaScript ecosystem. So if you are encountering problems, you'd like other people to help you out on the team, maybe help lead some architecture efforts, let me know, and we can talk about that. So why talk about debugging? Debugging doesn't sound terribly sexy, terribly fun, but I really want to talk about it because I really don't think that we discuss it enough. It's one thing, you only discuss it when you need it, right? Who wants to talk about debugging when you're not doing it? But it's a pretty core part of our job. This. Let's think about what a developer does, right? Let's just split it up into 3 quick areas, right? We have plan, our code. Once we're happy with our plan, or once your PM is anxious enough, you write that code. And then you have to debug your code, and you almost never budget time to do this, but you end up spending a lot of time doing it. And I would say if you just had to split up your time into those 3 areas, just think about it kind of mentally, and calculate maybe the last week, the last month. I would say that the thing that happens least in our time is writing code, especially writing it for the first time. And writing code for the first time is really, really fun and really awesome. It's probably why we got into this. You probably didn't get into this because you love debugging. You got into it because when you write it for the first time, it's really, really exciting. But we're not usually doing that. We're not usually focused on writing for the first time. And so for all of our talks to be about writing code for the first time might be a little bit like, let's say you wanted to be a better partner in your relationship. And you went to look for some books on relationships, and you found that every book you found was about how to have great first dates, right? First date's really important. That's cool. That's awesome. But if you have a month-long relationship, your first date happened on 1/30 of the days. This becomes a diminishing part of your relationship. The first date isn't terribly important. What's way more important is doing something like deciding where to eat when neither of you cares. Or maybe deciding which TV show to watch when both of you care very much. It's about something like conflict resolution, right? And I want to talk about debugging because that is the conflict resolution of programming. This is where we go to figure out why what we desire in the world and what we plan for the world just doesn't quite happen. So what to expect from this talk? I want to talk about techniques. I really don't want to talk about tools. If you've talked to me before, you can see I'm pretty bored with tools. I'm very bored with, hey, those things are really fun, but I'm just nervous that we're a little bit too attracted to them, right? It's like a bright light, we're all the moths, we fall in love. Don't worry too much about the tools, they're really, really helpful. But if you think about the philosophy behind those tools and the techniques behind them, then you can pick up and move somewhere else. And then you can develop some deep expertise. And I want these to be lessons for any software engineer. So if you're still in a code school, it could be very useful to you. And if you're a senior engineer with more experience than me, maybe they could still be useful to you. This should also be relevant for any discipline, right? If you're a mobile engineer, if you're an embedded engineer, there's probably no embedded engineers here. We're all on websites, let's be honest. But if you're in Ruby, if you're in JavaScript, if you're in Python, these should all be useful to you. I'm not going to show you, there'll be no monospace font. There's a little bit of code, but it's in Helvetica, so that I can't write too much of it. We're mainly talking about the ideas here. And maybe, if I really knock it out of the park, I'd like to stimulate some deeper thinking about what I think is this core piece of our job. And this has been a research project for me that I've gotten really geeked out about over the last half year. And so if you have ideas about debugging, if you've found a new technique you really like, if you just rephrase what I said back to you, it might stimulate something new in my head. Like, I would love to have those conversations. I'd love to think about debugging and talk more about this. So here are my research methods. How did I prepare for this talk? Well, I used some historical observations, which were my own numerous screw-ups, all right? Those times when you spend days and days on something that was sitting right there in front of you. I conducted some interviews, which consisted of bugging all my friends and asking them how they debug problems. I sent out a questionnaire. Basically, I slacked all my coworkers and made them answer my question. And talked to people who have encountered very different problems than I have. It was really, really helpful. And then I had a nice case study. I had a very well-timed, very serious bug happened when I first got the idea for this talk. And so it was really good because I got to live it. I got to see if any of this was worth a damn. So I'll give you a quick background on my thoughts on debugging. So debugging is hard, and we should reflect just very quickly on why it would be so hard. Well, first of all, we covered that it's much less fun than building, right? So every time you spend time debugging, you're thinking, I wish I was building right now. This isn't so great. It's full of failures, right? Like debugging, by its very nature, is full of failures until you're done with it. So there's one moment in debugging that's fun, and that's when you're done with it. It's also unbounded, right? It basically suffers from the halting problem. So if you think about your problem, you don't know when it will end. It's like a marathon, but someone didn't tell you how long you'd have to run for. Also, we're never taught to do this. Very, very rarely are you taught how to do this. You're taught how to use some of the tools, like a print statement, or maybe you're taught how to use the Chrome debugger, but you're not really taught how to think about them. So like, here's some tools, fix your problem, and get back to your real job. And all of this might make you despair, and you might agree with my friend Thomas Fig here, who said that the biggest mistake in programming is optimism. Now, I am not a misanthrope. I'm probably too much of an optimist at times. And I want to show you that we can get out of these situations, this debugging, and you can enjoy this core part of your job. One of the things that makes debugging so hard is that our view of reality is simply wrong, right? We assume something will happen and it doesn't. So part of the process of debugging is simply changing your mind. And this can be really hard. If you need illustrations about how hard it is to change your mind, just read the news, right? Or talk to someone who lives in a different county than you do about their political beliefs, right? It's very hard to change your mind. And this is not changing your mind about politics, but it's changing your mind about the core assumptions you're making about a piece of software that you wrote or someone else did. And it's important to note that code always does as it's told, right? Computers are nothing if not very diligent. They always do as they're told if given enough electricity. But code could still lie to you while doing exactly what it's told, right? And basically we lie to ourselves and we use computers as a misdirection here, right? So I really like this quote by this programmer named Chris Granger, and he said, the majority of programming errors are translation mistakes. You had the right idea, and it just got messed up in translation. And so the reality is wrong, but the plan was right. So some of the ways that we might mislead ourselves or lie to ourselves are namings of files. Maybe they could be classes, methods. Anything inside of your code could be misnamed. I mean, just think about a bug where you call a method called user.delete and the user isn't deleted. So the method name, in a way, is lying to you. And so it's going to create a mental block for you because you're like, I'm doing exactly what it should be doing. You're like, I'm calling delete. Why isn't this happening? And so you're going to have to get over these barriers. Also, in any significantly large code base, that complexity is going to hide a lot of the details from you. And you're going to end up glossing right over something that's right in your face, but it just turns out it's surrounded by many, many other things. You're trying to catch the forest through all the trees. So I'll talk a little bit about some of the frameworks that I've used in the past to think about debugging. So I mentioned this earlier, but I think a great definition of a bug is simply unexpected behavior, right? We make an assumption about the world, and it turns out that that isn't what happens. So let's think about those two things. Assumptions, and I'll call it execution. That's really reality. When your code runs, that execution creates a reality. And so we'll think about this. All bugs are incorrect assumptions. And so to figure out where you're wrong in your assumptions, you can use something like the hypothesize and test loop. This is very similar to scientific method. If you remember, 10th grade biology, first you would state a hypothesis, then you're going to test that hypothesis, a little bit more about that test later. You're going to see whether your hypothesis was right or wrong, and you're going to create a new hypothesis based on this new information. So it's pretty simple, maybe said with big words like hypothesis. It doesn't make too much sense, but we're not talking about software testing. We're not talking about Jest. We're not talking about any frameworks or anything like that. We're just talking about going out into the world and seeing what's wrong, right? Like if something shows up on your let's say you get a template tag on your homepage as opposed to the text you thought would be there, well then you might have an assumption that maybe use an escape character somewhere accidentally, right? That would be your assumption, then you can go off and test it, see if you're right. If you're right, happy days, you're done. If you're wrong, you should use that new information to improve your next hypothesis. So each progressive hypotheses should be a little bit closer, right? We should be moving in, I think about like moving in the bookends, right? We're trapping the bug, hopefully. And so it's less of a loop we're going through and kind of more of a spiral. And this spiral is an example of why I did not go to art school. I tried to freehand this. It took me about 10 minutes, and this is as far as I got. But think about this shitty spiral when you're debugging and think, how can I make the loop tighter and tighter and tighter? How can I narrow in on the problem? And I will warn you that this is great in theory, but sometimes the bug slips out of that spiral. Sometimes the system was more complex than you realized it was, and hopefully some of the techniques can help us with that. So to find a bug, you basically make an educated guess. You need to make an educated guess. That's going to be your assumption, and then you're going to go test that. And so to find the bug, either get more educated, find out something new about the system, or just make more guesses. And I think that's really important. And we'll find ways to double, quadruple, increase by 10 the number of guesses you can make. And I will note, this is a minor detail, but also save your work. Keep track of your progress. Because in any significant debugging process, what's going to happen is you're going to lose the bug. It's not going to reproduce. You're going to change the system somehow. The bug doesn't reproduce, but you know you didn't fix it because when you go to your production site, it's still there. And so Git or tools like that can help you save your work as you go. So now I'm going to get into some techniques. And I've divided the techniques up into two different categories. Some are debugging you can do at your keyboard, and the others are things you can do not at your keyboard, somewhere else. Maybe at a park, maybe somewhere nicer than at your keyboard. So the first one, and I think we've all done this, right? So some of this is going to sound obvious to you, and I hope you don't get angry with me. I hope that you have new language to think about why you're doing what you're doing. So let's think about verify path. This is probably the simplest thing you can do. You just want to verify that the execution order is what you thought it was. And this is what we're doing usually when we do console logs that say like, here, this part of the code ran. Or you run a stack trace. That's a very, very useful thing, just to see every single function that was invoked before this function. You can even throw an error. So like one very common thing might be in a class or in a component or something called member login, just print member login right there. JavaScript has a really great tool. It's console.trace. This is available in most JavaScript environments I'm aware of. And this will basically give you a stack trace. So this will tell you, you called console.trace in this function, and this function is invoked because of this. And you'll go all the way down the tree until you have basically your main program, whatever was invoked on the command line. Ruby also has this with the global caller. I don't think there's any modern language that would be without this. Also, a very quick hack is simply to throw an error. Throwing an error will probably halt your program, and in many systems, it'll just give you a stack trace. So if you want to know that you got somewhere and you want to find out how you got there, an error is a very quick way to do that. So now I want to talk about what I believe is probably the best debugging technique. And I think in some ways, all of them can boil down to this thing. And it has some long words in it, complicated words. It sounds like mathematics, bisect. But we're going to get through it. So to bisect, you would start with 2 points. And don't think about what those points are yet. We'll get to the specifics later. But one before the bug and one after the bug. And then you want to test somewhere in the middle, ideally in the center. And because we're not measuring with anything specific here, it's going to be hard to find the middle of those two things, but roughly approximate what the middle is. And then you should be able to find out which side of the bug, or which side of your division the bug is on. And once you've bisected, once you've split your code in half and you know which side it's on, then you can split that half as well. So this was proposed in a 1980s paper as wolf fence. So the idea was if there was a single endangered wolf in the entire state of Alaska, what you might be able to do is you might be able to create a fence. And then you might be able to listen along that fence until you heard the wolf howl. And then you would know which side of the fence that wolf was on. And so then you'd take that half of Alaska and you'd divide it into half again. So now you'd be dealing with 2/4 of Alaska, 2 different fourths. And you'd find out which side he howled on then, and then you divide Alaska up again into 8ths, right? And so we're decreasing, we're having our problem every time. And this is actually a mathematically optimal way to solve the problem. Now again, it gets a little bit squishy because we're not quite dealing with numbers here, we're dealing with bugs, but it is a very, very good technique. And in fact, this is how you would find a number in a sorted array or something like this. Like if you go back to your computer science fundamentals, they use bisection. And so this is a very, very helpful debugging technique. And there are 2 ways you can bisect a problem. So we're going to jump into this a little bit more. We're going to think about bisecting the execution flow and then bisecting the code history. So if we think about the execution flow, let's take the code that's running, and we're just going to cut the code path in half. So let's think about our UI shows us something incorrect. A piece of data is incorrect. Someone's name might be incorrect or malformed. But I know that in the database, it's correct, right? So I have my UI way over here, and I have my database way over here. And a lot happens in between. And I don't know where the bug happened. I don't know where this formatting error came in. But I can test right in the middle. And maybe the middle in this case is an API response. Communication from the server to the client. And so I can test there. And then I can see, does this error show itself yet? And if it does, then I know that it happened before the split. I already have the error. So I've eliminated half of my system. This is very, very helpful. Eliminate half of your system at once. If the error hasn't shown itself yet, then I know it's entirely on the front end. So this division can be exceedingly helpful if we think about the execution flow. Now we can twist things and we can think about the situation totally differently, and we can think about bisecting history, changes made to our code. And many of you might have done this technique, right? So take the history, and you know that the bug didn't exist on Monday, right? But but maybe it does on, let's not worry about those days I put, they're incorrect. But let's say it happens on Friday, right? So it wasn't there at the beginning of the week. It is there at the end of the week, so I should test in the middle of the week. I should see what was the state of my code like then. And I should see whether it happened. And in this way, I'll be able to bisect and get closer. And Git actually has this built in. So there is literally a Git Bisect command. It's a little bit confusing, like any other Git power tool, and it can feel a little bit unwieldy, and you can tie yourself in knots if you're not careful. But it is a very useful tool, and it'll do exactly this. It'll help you pick a commit right in the middle of where you are. Now I will, as an added tip, I will say that squashing your code, taking all of the commits for your PR and making one commit out of them, is very, very helpful for many things. It makes your history more readable, but it also makes something like Bisect actually work. If you don't squash your commits, you could run into a lot of, it would be very annoying to use this technique because you might end up right in the middle of somebody's hack. They did 7 things, I had to fix lint, and they had to fix this, and they had an error here. And Bisect could land you on one of those. So if you're ever on my team, I'm gonna make you squash your commits. And if you'd like to be on my team, you could practice now. Another technique is to trace, right? So Bisect, we jumped around. We said, things are good here, things are bad here, let's test in the middle. Well, sometimes things can get a little squirrely and the bug might not be able to be narrowed down like that. Maybe it's a more complex system and a couple of things need to happen. So what a trace allows you to do, and I think many people have done this is basically the primary way you do this as a stepwise debugger, is you walk through your code and you watch a piece of data go through the entire system, and you see when it transforms in a way that maybe you don't appreciate, maybe you'd like to fix. So if we think about our previous example, we have data is good in the database and bad in the UI. As opposed to jumping to the middle, let's just go the step right after the database, right? So how about the database query in the app? Did I have something wrong in the query itself? Was there a character in MySQL that got appended to the data or something like that? That would be tracing the data through the system. So a different approach. It's kind of like the logical opposite of the bisection. The next technique is to delete code. Just go ham. Just remove things. And the idea here is that anything you remove while being able to produce the bug didn't contain the bug, right? If I pull out this piece of the system and the bug still exists, then I know this piece that I'm holding probably didn't have anything to do with the bug. Now I can say probably because they're pretty complex bugs that might have something to do with that, but it's a very, very, very good technique to use. This also simplifies the system so you're just looking at less things. You're holding less in your head, and the hypotheses you create in the future don't have to account for the thing you just removed. It also speeds up the test loop, and we'll talk later about your ability to test this thing is going to determine how fast you can narrow it down. So again, source code is your friend. Make sure you save your work, because you're going to get to the point where you said, ah, shit, I deleted it, and now the bug is gone, so I need to go back. And you need to have an efficient way to go back. Git is a very, very efficient way to go back. You should be making lots of branches. Don't be afraid to make branches. They're very, very cheap. Make branches in Git. Use them. This can be automated as something called delta debugging, which is a pretty complex debugging technique. But essentially what delta debugging will do is it'll take your source code and it will delete things, rerun the program, see if the bug happens. And it'll just do this progressively. It'll use a bisection method, very similar to that, and just remove a lot of your code. I don't know if many people that do that use a technique like that, but that is out there. We could also think about the logical opposite of that, which is to rebuild the system. Not the whole system, just enough to reproduce the bug. So if you have a bug in a form on a very big page in a very big app, it might be easier just to build a very small form, maybe in like a code pen or even something simpler to reproduce the bug. Because if you're trying to iterate on that huge system, it's going to take you a long time. Maybe your build process takes 30 seconds, and to waste 30 seconds as opposed to building up a smaller system is going to be a waste. So again, this is basically the logical opposite of deleting. I alluded to this earlier, but if you can test your system faster, and again, I don't mean running software tests, I don't mean running Mocha or Jest, I just mean finding out whether your assumptions are correct or incorrect. And this has, I would say, two different distinct benefits. The first is that if it's easier to test, you're more likely to test things, more likely to not give up, keep at it, and you'll be able to test more. Also, it enables you to keep your flow, keep your focus. Because it can take so long to get focus on something, and then you have to wait 2 minutes for your system to build. You're probably going to go check Slack or Twitter. You're going to get lost mentally. So you can keep your flow if you can test faster. There's a few ways to test faster. One is to automate manual actions. So let's say that your bug on a UI only appears when a dialog box is open. Well, then just automate the clicking of that box. Some way make it so that that box is already open so you don't have to click it and go through that process. Remove some of the UI. Right? Like many times what I'll do is I'll change my router to route me right to the bug so that every time my page refreshes, I'm at that exact place I need to be. You should minimize the setup. Again, like remove pieces of the code that don't matter that help you get to this spot. If your bug is on the third page of a form, just remove the first two and just have that be the first page, right? You're worried about solving the bug, not putting your code base in a place that you would ship it. The next is to refactor, and by refactoring I mean a very different thing than rebuilding your system or deleting your system. I mean that you would immerse yourself in the code base, you would learn about the code. Don't worry, it doesn't offend me, that's my own child. It really is, it'd be creepy if I said that about someone else's child. It would be very, very creepy. But you can learn about the system by refactoring it, right? By changing a little bit of it, in a way kind of making it your own. And I think all software engineers have this desire. They want to tinker with things to see how they work. And I say, go for it. Like, take that desire and act on it, right? Rename things, mess around with things, refactor them, and you're going to do two things. You're going to learn more about the system because you're forced to interact with it and think about it. And then you might just fix the bug accidentally, right? And then you can make much better assumptions about where that bug might be. It's like, oh, I was refactoring this method, something changed, okay. It might be something this method is calling or a piece of manipulation that this method has. I don't know if people have seen some of Sandy Metz's talks, but she has this great idea of the Squint Test. And what she says, you just squint at your code and you should be able to see what parts need to be refactored. And so if you see extreme nesting, kind of your code lines getting increasing to the left, that probably means you have a lot of nesting and you probably have a lot of conditionals, and conditionals are very, very hard for us to think about. Just 2 or 3 levels of conditioning, of conditionals is very, very difficult for you to enumerate. And so removing those might help you out. The other is just to think about the way color changes in the editor. And if you see a lot of different color in an area, there's a lot of different types of entities. There's objects and booleans and type checks and things like that that maybe shouldn't all be there in the same place. Maybe like should be with like. And again, reminder, save your work, right? The last thing you want to do is get in the middle of a very big refactor and then break it even more, create more bugs than you had. Next idea is to multiplex, right? To run many, many small tests. Again, test is a, in quotes here, this isn't a proper software test, but you want to test many of your assumptions at once, right? So one way to do this is to put an assert statement in multiple places. So what an assert does is a function, and you say that I'm assuming that the object coming in has this shape, or I'm assuming that this Boolean is true. It's basically what you would use in a proper software test inside of Jest to say this should be correct. And if you place these all around your code, most of them are going to pass just fine. But if you make your assert fail and crash when it's wrong, then you're going to go hopefully to the closest place in your code that has that error occurring. And so asserts basically allow you to multiplex, because if you put 17 asserts in your code, then what you're saying is, I assume that in 17 different places, everything is good. And if one of those fails, then you ran 17 tests and you got one very, very helpful result. But remember, if one fails, the other 16 passed, and so you also get results for those too. So it'll probably help you narrow things down. This is a technique that one of my coworkers told me about, and it's not something that I thought so much about, building for debugging. And the simplest way you could build for debugging is honestly just to build a little bit better. Like some of the best practices we have are not because the code runs faster, it's not because the code looks more elegant, it's not because it's a smaller package size, it's simply because it's easier to debug, it's easier to think about. And sure, maybe it's like easier to extend later in the future, but honestly, debugging is gonna happen way before extension. And so think about smaller functions and classes and components have less state. State is the place where most of your bugs will be involved. Not React state, but just state in general. Anytime your system has to hold some sort of piece of data in mind and mutate that over time, that's a great place for a bug to live. You can also put in strategic logging right in the application by default. And I say strategic logging because if you have too much logging in it, you're not going to be able to see anything. So be smart about where you put logging, but API responses and requests are very good places to put a little bit of logging in so that you can expand that and see what's going on. Also think about things like a Boolean expression, right? A very cute looking Boolean expression, like maybe a bunch of these ors here, or God forbid a nested ternary statements. Like these are really nice, you know, they allow you to write very terse code, but they're gonna be very hard to think about. And I bet you a bug could live very easily there. So think about just if statements or switches. Do things more explicitly. This is one of the, I don't know if people have seen the Zen of Python, but this is one of the be explicit is better than implicit. So even if you have to write a few more lines of code, be explicit. Also, I think that the simple act of renaming things, renaming your variables, your components, your classes, can be very, very helpful. Because it basically forces you to enumerate your assumptions. Because a name should wrap up a lot. I assume you aren't naming your variables X, Y, and Z. Like, I know programmers that do that. They're usually very, very good by themselves, and that's it. They write very, very good code by themselves for the first time. But it's going to be hard to iterate on that. So I have an example here. You could think about a component called highlighted card controller, right? And then you're forced to ask yourself, if you want to rename this, is it really only on highlighted cards? Like, what would happen if the card I gave this component was not highlighted? Would all hell break loose? Would things work just fine? And this is an assumption I'm making, and it's causing me to look right past the bug. And the last thing I would say about things you should do at your computer is you should read. You should read more code. Now, I've heard someone make the pithy statement that if you went to an author's house and you saw that that author had no books except the books he wrote, that would be a red flag, right? You don't want an author who's not very well read. And you probably don't want a programmer who only writes code. You want to be reading code. You should read code for your own edification, and when you're solving a bug, you should probably be reading code like the code sitting in front of you, the code unrelated, well, supposedly unrelated to your bug, but you don't know yet because you haven't solved your bug. Maybe you should read code from the third-party libraries you're using because they may be doing something with your data that you didn't think they'd do. And essentially, if we're making educated guesses, we want to become a little bit more educated about the system. So now let's think about debugging that we can do not at our keyboard, somewhere else. And these are going to be, I guess I would call them softer techniques, right? These involve thinking and talking and interacting, maybe, with other people. So the first one would just be, try to break out of that mental block, right? Because if you are incredulous that this bug is happening, which all of us are, right? You're like, how could this happen? What you're basically saying is, it's not really happening. It's not happening, there's something, no, it's the user's fault. Like, there's no way. And so I would encourage you to imagine a world in which this happens. And imagining what that world looks like will probably lead you to some pretty good assumptions about where you should look next, right? Because your intuition about the code base has been built up over time, and if you're really forced to think about it, I bet you could imagine a reasonable place for that bug to live. Another great technique is just to take someone, really anyone who will listen, even if they don't program themselves, and just talk with someone about both the system, about the desired behavior, and about the bug, right? This is going to force you to walk through the system. And this is called rubber ducking, right? The idea is that you could take a rubber ducky, not a person, just looks animate enough, and you could look at it and explain to it the system, and you're gonna have a moment where you stop and say, wait, I got it. I figured it out. I was forced to articulate myself. Speaking something out loud is different than thinking those exact same words. That's not how our brain works. We don't think in words. So when you're forced to articulate them, you might walk through the system in a different way. It's also going to be more challenging for you, and you'll probably think, oh, I don't understand enough about this. I really need to look into this more. Another idea is to take someone who does know something about the system, something about programming, and consult with them. And the key is that they haven't been staring at the same bug as you. That's really, really important. Because your ideas have gotten really narrow. You've gotten really entrenched in what you believe about the system, what you believe about the bug. And if you talk to someone new, they're not going to have those same biases. One of my favorite books, very short, is Kuhn's Structure of Scientific Revolutions. And in this, he's a historian of science, and he notices that most of the great breakthroughs in science, the paradigm shifts, where we totally change our mind about things in science, happen from two different types of people, from people young in their career and from people totally outside the field, right? Everyone knows that Einstein was not a physicist before he became the greatest physicist ever, right? He was a patent clerk. He was doing a menial job at a menial profession. Like, he wasn't doing the work of physicists. And that enabled him in some ways to think totally outside the system. And so we're not doing crazy work like physicists, but it is helpful to have someone who isn't as biased, who isn't as entrenched as you are. I've talked about this before, but I think this is a great thing to do when you're not at your laptop, when you're walking, you have a notebook, maybe you're at a whiteboard. You could just enumerate your assumptions about the system. Just walk through them, actually write them down. Like, I'm assuming that this data is delivered from the database to the UI without any mutations. Oh, now that I say it out loud, I guess I better check. Did something happen to the data in this piece, right? Enumerate those assumptions you're making. And be thorough, even if that feels ridiculous. Try to be thorough. And then look at them and think, which of your assumptions do you doubt the most? And that might be a good place to look. Because remember, there is a bug. Something is wrong. One of your assumptions is wrong. And if you get them out on paper, you might have a guess as to which one of them is wrong. Another way to do this is to journal, right? To keep track of what you've done. Because you can't fit the entire complex system in your head, so try to walk through what you've done. And sometimes I even have a log. It's like, on Monday I did these things, and I found out this about the system. And that way, I can go home, I can relax, and I can come back on Tuesday, and I can open up that document and say, okay, I did this before, I left off there, now I can get back at it. And one of these things, like the second to last point there, is that this could really help stave off the burnout. Because you're going to feel like you wasted time. It really, really sucks. And maybe your manager even thinks you wasted time. And you can say, okay, here's what I've done. I've kept track of it. I've tried all these things. I feel like at least I've put in some effort here, even if you haven't gotten results. And of course, writing the things down can help you gain a different perspective. And the last thing I would say is to walk away from the problem. And I don't mean this just for your own mental health, although that is definitely a factor here. If you're getting super stressed out, maybe you should take a break. But there's also something pretty magical that happens when you take something that was in all of your attention, and you just kind of shift it, right? This is the phenomenon when people are really trying hard to learn a new instrument like a guitar or something. And they can't do it, and they're staying up late. They fall asleep, they get up the next morning, and over breakfast they just try it, and damn it, they have it. They can do the thing that was so hard the night before. I don't know how our brains work. I don't think anybody really knows how our brains work, but there's something about them that a little sleep or a little time away can be helpful. I had a professor in college that helped me understand the idea of like calendar days. He said if you're going to make a very important decision, you have something very important to do, try to think about it way before the fact, and then don't do anything about it. Just think about it a little bit, and it's going to sit there in the back of your mind, or you're going to have one of those shower thoughts, right, where you're doing something totally unrelated to the task at hand, and then you're going to think, oh man, that's what I should do. So just allow yourself this. Walk away from the thing. This might be hard to sell to your team, but you're like, hey, I need to work on something else for a second. I'll get back to that, but I just need to allow myself some space from it. So I listed out the debugging techniques that I have enumerated earlier if you want to take a picture or whatever. But again, I would love to talk about this. I'd love to hear your experiences, how you track down some of those bugs. I'd like to keep adding to this list because I don't think it is in any way thorough. Thanks so much, y'all. Do you want to do questions at all?
You want to take questions?
Yeah. We have a quick time for questions.
Here. You can keep this one.
I like this one. It's a very good mic. What number is that? It's number 1. I didn't check what number it was.
Okay, this is on now. No, it is number 1.
So. Anybody I don't work with? No. let's do John. All right.
This is when they get to roast you publicly,
Yeah,
Chris. Come on.
no, this is not scripted. This is going to be bad.
I'm going to make this happen.
So, Chris, I noticed you're very bad at debugging, actually. Do I need to remind you what a question is? So it's a short.
Well, actually, no. I just wanted to know what your personal threshold is before you ask for help. So say you're debugging a problem.
Yeah, absolutely.
And we're all a little prideful, right? So when do you make that determination?
So I think I have a different bias than most people in this industry, and I think I asked too early, honestly. I find myself doing this all the time. Like I'll Slack like an entire channel of people, and I'm like, even in the process of typing out the question, I realize it. So for me, I think the threshold is a little bit lower, and maybe it's too low. I know some people, like I would definitely say it should be measured in hours, not days, right? And maybe it should be measured in minutes. It depends on the system. It depends on how complex it is. It depends on how experienced you are. If you're the most experienced in the system, you probably need to take a little bit longer, because someone else might not have the answer for you. But I think for me personally, it's something like 2 hours, maybe an hour. Yeah. Anything else? Thanks, John. That was really nice. That was an easy one. All right. Oh, sorry.
Oh, no, that's fine. So I'm wondering, what sort of tactics might you use to help you like test things in like concurrent systems, like when you're dealing with like multi-threaded type things or things that you have to like mock out? Like, what do you find most useful in that whole environment?
Yeah, make them not concurrent. Is first. No, I'm very, very serious. Very, very serious. If you have a bug in a concurrent system, make it not concurrent, and did the bug happen again, right? Because you're going to learn something very quickly. If it doesn't happen in that system, now you have a simpler system to test. If it still happens when it's not concurrent, when it's serial, then you know that the bug isn't because of the parallelized code, right? If the bug disappears, now you have something that's probably like a race condition, right? And race conditions are a different class of bugs, and they're harder to troubleshoot. I guess very quick, a race condition is a bug that you don't see all the time. Like, let's say you run your code 10 times and you see the bug 5 times. And that can be maddening. And what it probably means is it depends on the exact execution flow. And maybe if this API request takes a little bit too long, this one finishes earlier, then the bug happens. But if they happen in the reverse order, you don't see it. So concurrent systems, this can happen a lot. So I would say, first, make it not concurrent. If it still happens, then we have to deal with race conditions. And then I would use, because in a concurrent system, if you have a bug and it doesn't happen in a serial system, then it means that it involves at least 2 pieces of the system. And so now you have an annoying piece where you have to decide which piece it was. And honestly, I'm not sure where I would go. I think we'd probably have to talk about specifics or think about a whiteboard. Yeah. Questions from the back, always the worst. Oh, man. Be nice, man.
He must know you. I'm sorry.
I haven't eaten yet, so I'm a little weak on my knees here.
I'm still newish to testing, so I just started using Jest and Enzyme for the most part. When you were talking about those assert statements, is that part of the testing library, or is that something else? Because I wasn't familiar with that, and that sounded kind of interesting.
Yeah, so that it could be part of your testing library, but what I would say is most times you have a bug. I don't know, maybe everyone writes better tests than I do, but like most times when I have a bug, my test suite didn't cover it, or I would have already fixed it. And so first, the very quick question is no, we're not talking about assert statements inside of your testing library. We're talking about statements that do exactly the same thing, but they're not in the context of your test. They're in the context of your application. And so you would just import a library. There are a couple pretty decent ones, or you can just write your own assert statement. Really, like, probably what you're doing is this thing deep equal to this thing? If not, throw an error right here. That's as simple as it really is. And maybe you put a string after that to describe what the hell you just did, so that when you're looking at it later, it makes sense. But they could be very, very simple, right? It could just be low dash, deep compare, A and B, throw an error if they're not equal. And then you're going to say things like, is this object what I expect it to be? And you're going to put that all over your code, and then one of them ideally will fail.
Would you keep that in your code then once you're, say, done with that branch or whatever? Are those things kind of like maybe console logs, you wouldn't take note of them and pull them all out?
So I think that's actually up for debate. So some people like assert statements to exist in their code, and usually they will remove them at compile time, or at a production compile time, right? Because you're like, I definitely don't want the users to crash on this, but I don't really even want to run the logic of comparing things, because that could really slow down if you have 1,000 of these in your code base. So I think there's a pretty good, and I think Facebook has a library, I think it's just called Assert. I could be wrong. But I believe what it does is it removes itself, essentially, at a production compile time, but it stays there for dev compile. I don't really like keeping too many extra things in the code, because then when someone goes to create new code, they don't know how they should do it. Should I create an assert statement in my brand new method or not? And what would be a smart assert statement? Because sometimes I think we're just guessing. It's like when you write a trivial test. It's like, well, 1 should equal 1. It didn't really help us at all. And so I don't include assert statements, but I think there's a reasonable case for saying you should.
Yeah, because I didn't know if they could almost be used as like commenting in a way. Like obviously it notes that this was a point in the code you expected a possible conflict, and that might help actually read the code later on.
Yeah, totally. That is absolutely the dream of them, right? Like that's how it's sold, and that's how testing is sold, and things like that. I haven't seen it borne out in reality, but that doesn't mean that it can't be there. It might mean that I'm a bad engineer. I don't know. But yeah, I think you could go either way, and you could go either way very reasonably, which is the most annoying answer. I'm sorry. Anybody else? All right, we'll move on. I'll let you. We're gonna do job announcements.
Yeah.
Take it away, Kevin.
Cool. Thanks, Chris. Everybody give Chris another round of applause. All right, so yeah, we're going to take a quick break. If anybody needs to run to the restroom, get more food or anything. While we're doing that, anybody who has, if you have a job that you're hiring for and you didn't write it up here, feel free to come and write it up here. If you already did write it up here, feel free if you want to just kind of, quick kind of intro, 30-second kind of about you guys, about the company, what you're hiring for, whatnot. Yeah, so if there's anybody that wants to do that, come on down. Otherwise, we'll kick off the next talk in 5-10 minutes. So, thanks. With the mic still? Just like keep going? Yeah.
Hi, I'm Krista with Valdez International, and we are hiring a JavaScript React developer to work on a web portal for the federal government. Yay, believe it or not. So if you're interested in talking about it, let me know. I can hand you a business card. We have somebody that also works for us as a developer. Kristen, you can take her off and ask her questions about how horrible or good it is, and she'll hopefully answer your questions.
Cool. I'm Stephen Noy. I work for this company called Plyport. It's a software startup basically that's kind of like trying to revolutionize the way we encrypt files and secure files. We're looking for a senior React developer, kind of basically to do our portal and kind of the UI for it. So if you're interested in that, I'll just leave a couple of these cards up at the top here, and you can grab it if you need it.
Thanks. Hey, I'm David. I work for Exactly. We're the sponsor for this event, and we have lots of jobs open for quite a few new teams that we have. So I work for Exactly. We do sales planning software, similar to kind of what Salesforce does, but we partner with them instead of compete with them. Kevin is also here. He works for the company. So if any of you are interested, please feel free to come talk to us. We have back-end, front-end, quality, and data science jobs, so the full gamut.
Hi, I'm JK. I work for Fluid Truck. JK is actually, I go by JK. It's James Caleb. But so when you see that email up there, JK at Fluid Truck, it's serious. So what we do is we're a truck sharing app, and you may think, oh, we've got a lot of sharing apps these days. We're a little bit different. Think about U-Haul in the 21st century. If a user can unlock and lock their vehicle from their phone, etc., we have a lot of that technology already built. We're hiring a few positions. I didn't get the memo about the sponsor column job thing, so I accidentally wrote Fluid. Okay, cool. Co-sponsor, all right. I'll buy something. But yeah, so right now we're hiring for a senior front-end engineer. We're hiring for senior full-stack engineer, running on Elixir and Phoenix in the back end. Full-stack engineer is a must-have first, doing some mobile dev with React Native. And then if you're a junior dev, you have like 3 months to realize you don't like your current job and apply for us. And about 3 months or so. Thank you.
Anyone else?
I'm Eli. I'm from Ionic. I'll be doing the talk coming up next, but I just wanted to announce that we are actually hiring a couple of engineering roles. We got like a senior front-end developer type role, working in a bunch of different types of technologies from React to Stencil to Angular, that kind of stuff. Best part about this job is that it is very remote friendly. So I work here in Denver, but we are based in Madison, Wisconsin. And the other job is a solutions architect. So if you love working with customers, kind of not really a consulting role like building the apps, but like just being like an expert to help them with their problems and whatnot, maybe help them kick off projects and get them started. We are hiring a solutions consultant role as well. So if you're interested in that, come speak to me.
Cool. Looks like that's it. Continue with breaking.
Yeah, let's we'll kind of reconvene in like a few minutes at 10 after.
If you're still hungry, please get more food. You just turn off.
Yeah, I just turned it off. Turn it back on.
I think you just tap the red. But it's confusing because then you tap it and it says RF mute off instead of being like mute enable. I almost wonder if it's like a click. Yeah.
Oh no, that's not me.
Like click and then click again.
You can't rename that while you're voting. I'm just going to turn it off.
I know, I'm like, does it off mean it works or it doesn't?
Yeah.
If the boom mic works or if there's any
Yeah,
mics.
you can use this if you want, if you prefer to use that.
So we'll be doing some.
Yeah, totally. These things are a little tricky. Oh, here we go. There's a mute.
Test.
You want this?
No, it's a little shaky.
Hello. All right, we are going to start back up. Last chance for drinks and food. All right. All right, so next talk is mobile apps with React and Ionic from Eli Lucas. And thank you so much for coming.
Thank you.
Oh, also one quick thing, sorry. All this stuff up here is free. So as you're coming out, peruse it, and if you want anything, feel free to take it.
Sounds good. Can everybody hear me okay? Am I coming over the mic? Awesome. All right. Well, welcome. Thank you for coming. My name is Eli Lucas. I am a software developer / developer advocate, and I work for a company called Ionic. Who's heard of Ionic? Awesome. Who here thought like Ionic was only for Angular? maybe a couple of hands. Good. That means a little bit of perceptions are changing a little bit. So historically, like Ionic was built on top of Angular, so you had to like use it with Angular. But with our V4 releases, it was actually like re-architected, rewritten in web components, which means that we can now work across a variety of different frameworks. So I'm here to talk to you tonight about working with Ionic and React. And so what is Ionic? It's a UI library, mostly made for building mobile applications using web technologies. So it's a suite of components and libraries, about 100 different widgets inside of there, stuff that helps you make your web apps look and feel like they belong on a mobile device. So things like tab bars and side menus and lists and the inputs that look and feel like they actually belong on mobile devices, stuff like that. But really, when we're talking about like mobile and React, a lot of us do React Native. Any React Native developers out here? Got a couple, okay. So like, what about React Native? Like if you're a React developer, that's kind of like the first thing that you think about. And like really honestly, like I love React Native. Before I went and joined Ionic, I did a project for about a year working in React Native. But our philosophies are a little bit different between Ionic and React Native. So let's talk about those a little bit. First of all, like I kind of mentioned a little bit earlier about how Ionic used to be only on Angular, but now it's been rewritten, completely focused on like actual web standards, not particular frameworks. So we're not locked into any particular framework anymore. And what I mean by that is that we're written using web components. And those web components can be ran inside of any browser that supports them. And then we also have polyfills that load automatically for those that don't support them, like Edge and IE11. But then we have like wrapper libraries that go around those web components. And these wrapper libraries make it look and feel like it belongs in the framework that you're building in. So when I talk about like Ionic React, I'm specifically talking about a library that we produce that you can download that is a wrapper around our web components. And so when you're actually working it feels like you're working with React components, not necessarily web components, because if you tried to work with web components inside of React, you might have noticed it's not necessarily the greatest experience. So that's what we do. And so our philosophy is that we want to embrace web technologies from top down. So React Native, it's kind of a hybrid type approach as well. You use JavaScript as your programming language. But then like when you're actually doing the UI work interoperates with some native controls that belong on those systems to produce more of like a native type app. With Ionic, we're web 100%. So that means that when you're actually writing your views, it's HTML and CSS and JavaScript and stuff like that. What happens inside of an Ionic app is that it loads up a web browser and loads the web pages that are distributed with your app into the web browser. And so you might think like, okay, so you're running in a web browser, isn't that going to be like really slow and whatnot? And you know, there's some valid things to pick out there, but the reality is that with phones getting better and better and the browsers getting better and better, the APIs are quite there, that really an Ionic app can look and feel almost just like any other native app out there. So I got an app right here on my phone. This is our Ionic. Oh, we can't see that. Okay, and so this is kind of our little demo app. It's called Ionifits. It's kind of a take on the Zenifits app, if you've ever seen that before. But really what we have here is we have a list of thousands of employees that work in here. And so one of the big takes about mobile is that like, oh, your list scrolling is going to be like really bad. And so like right here, like we got a list of thousands of employees here in this database, and you can see that as I scroll through it, it's actually going pretty nicely. And so this is using techniques that a lot of mobile apps use, like virtualized scrolling lists and whatnot. So it's not rendering everything at once. It's taking stuff out of the DOM, putting stuff back in. These are the kind of things that we provide for you when you use Ionic. And so you come in here, you can see that, you know, it looks and feels like an iOS app. Here I am, I can write an expense report, burn amount. Got access to camera. But not so, I mean, kind of looks and feels just like any other mobile app that you would use. And so like I said, like our idea is that our mission at Ionic is to like empower web developers to build mobile apps using the technologies that they currently know and love. So HTML5, JavaScript, CSS, and then the frameworks that you know and love, React in our case here. Kind of a nice thing when you do it this way is you can target more platforms because the web is ubiquitous. It is everywhere. And so not only do you get like iOS and Android, but you also get like Electron, so you can deploy your apps into Electron. And then the other big thing is PWAs, so progressive web apps. And so you can actually take your Ionic app, deploy it to a web server, and add a service worker, add an SSL certificate, and boom, you have yourself a PWA from the exact same code base that you're using to deploy to all the other platforms. So let's take a quick look at how it works. So you got your code, and so this is just the normal day-to-day code that you write. And then you have Ionic React, which is the library that you install inside your app. Now, if you want to deploy it to the stores, Apple and Google and whatnot, we have another project called Capacitor. And so you might be a little bit familiar with Cordova. Capacitor is our take on Cordova. It's kind of like a reimagining of Cordova. So it's built like back in the day, we used to really rely on Cordova. And like whenever you see like the Stack Overflow surveys and stuff like that, Cordova is like one of the most used technologies, but at the same time it was also like one of the most hated technologies, unfortunately. And so we were seeing a lot of that. And so our take was like, okay, let's write our own native layer, and that's what Capacitor is. And so Capacitor will take your web code, package it up into an APK file, an IPA file, gives you access to the underlying hardware system through JavaScript bridges. And so you can actually go in, write native Swift code, write native Java code, and then interact with it via JavaScript in your apps and whatnot if you need to get access to the hardware, like I was showing you with the camera here and whatnot, and then helps you with the deployment process to get to the stores as well. And then there's the native SDK. So this is the JavaScript bridges that I was talking about, so you can write your native code and have it talk to your web code as well. And so this is what the HTML for Ionic React app looks like. You can see we have a bunch of different widgets going on here. We got lists and contents and items and all the kind of basic stuff that you would like kind of expect from a mobile UI library. And to get started really easy, it's all node-based. And so you npm install Ionic, and this will install the CLI. To kick off a brand new project, Ionic start, give your app a name. The tabs is one of the templates that it's using. And then specify the type of React, and this will get you started with a React template. And then after that, you're pretty much running in React world. And so developing in it feels very much like we actually use Create React app behind the scenes. And so like all the commands, all the scripts and stuff that you're running from there is provided by Create React app. So let's dig into the demo. And so last night I was thinking, I'm like, okay, I'm not gonna give my like standard kind of demo. I wanna do something a little bit different. And I always think about like, okay, what could I write? What's gonna be helpful? And I got a bunch of kids. I got 4 of them, and they're joy in my life. But sometimes, they're like this, and other times they're like this, right? And so when it's like this, like my wife and I, we've come up with a system, and it's like a reward-based system. We're like, okay, every kid, things are different, but it's basically like, hey, if you can do something for a day, we call them warm fuzzies, right? And they're just like little balls, and like you put them in a bag, and the kids collect them. They collect so many of them. Hey, what's up? You collect so many of them, and they get a prize or whatnot. But they're really more interested in actually earning the warm fuzzies than they are the thing. And so we got this manual process right now of like throwing warm fuzzies in the bags for each of the kids and whatnot. And so I was like, okay, well, I can take this perfectly good system that we have right now and ruin it by applying technology to it, right? So that's what I did, right? So we got the warm fuzzy app. So let's go ahead and I'll show you the app here real quick, what it looks like. Let's see, React fuzzies. And so this is what we're going to build. So we got our list of kids, and then we see what their goal to earn a prize is for their warm fuzzies. Might be a little hard to see there on the screen. I don't think I can zoom into this, but then we'll click on the kid. Then we got this dialog, and then click on the buttons to earn their fuzzies. And then one of the nice rewarding parts of this is that it's like a celebration when they hit their goal, right? And so when they hit their goal, we do a little celebration. There's supposed to be sound here too, but we can't hear it. But all right. So let's dive into that. Okay, so I have an app that's kind of been a little bit like a Martha Stewart, like it's kind of prepared, and so I'm taking it over here. I've already ran npm or Ionic start type React, so you don't have to see me install a bunch of web dependencies. I've already installed a couple of dependencies from npm that's going to help us with some of the stuff in here. I'll mention what those are there. But besides that, this is almost the base project that you get out of it. So I'm going to open up Visual Studio Code, my favorite editor. Anybody else use code? Nice. Okay. It's almost not even worth asking that anymore. And let's see. Give you a quick tour of what the base app looks like here real quick. So it kind of looks like your standard React app. We got our source directory. You got your main index file, the entry point into the React app. And then you got your app file. And inside the app file, we got the routes listed for our application. This is using the tabs-based interface. So I'll show you that a little bit. A couple of things that you might notice in here is we have this Ion React router. And so this is a wrapper around React router or browser router. And that's the router that we support right now out of the box. It's going to be a separate dependency, so we are going to support other routers. But the reason why we wrap it is because to achieve the mobile navigation and the animations and stuff behind that, we really have to take control of the view rendering. And so we work with the routers to do that. And so you don't actually import React router into here. You import Ion React router. But then these routes and stuff, these are just regular React router stuff. So setting up a few routes. Here is our tab bar. Let me actually start this here in the background while I'm talking about it. And so we got a few tab bar buttons set up. This nice and big so we can see it, hopefully. Yeah. No, you can't see the whole thing there. There we go. Okay, and so we have a tabs-based interface here. And so I'm running in emulation mode inside of Chrome, and I got iPhone 10 selected up here. And so this app actually looks and feels and runs like an iOS app. I got my tab bars, my animations between everything look and feel like they belong on an iOS device. If I come up here and I select an Android device like a Pixel 2 and refresh it, the app automatically morphs itself to look like an Android app using material design. So down here I got the icons with the pulsating when you click on things. The header is now left aligned. Animations are a little bit different going between the two. And so this is something that comes free out of the box. So we call it continuity between the different app platforms that you get. So the first thing we're going to do inside of our app is we're going to create a new page. And this will be the kids list page. And I'll use a little snippet here to create the page for me. And so this is used in TypeScript. By default, we work with TypeScript out of the box. And so if you're not familiar with TypeScript, it's kind of a super step to JavaScript that adds optional typing into your application. I absolutely love it. I see myself like I would not want to work without it anymore, but it's a pretty cool stuff. But if you're familiar with JavaScript, you're going to already be pretty familiar with TypeScript. It just adds a little few extra things into it. All right, and then what we're going to do, and so by default, we also like support all the stuff that's latest in React, such as hooks. And so in this demo, we're going to be using all functional components with hooks. And I got my code fragments here, so you don't have to see me write a bunch of stuff. Real quick, I want to show you this data service. This is where we're going to be getting the data. So basically what's storing all of our kids. Don't need to dive too into this. It's using local storage. It's this database, and then you don't need to see my really bad code about going back and forth into local storage and whatnot. So come into here, and the first thing that we're going to do is use a useState hook to get the kids variables. I'll add me no code of action available. Let me import that real quick. Let's see. Okay, and so this is just an interface that defines our kid object for us. And so we got an array of kids coming back. And then this next thing I'm going to show you is a hook that is a part of Ionic. It's a part of our page life cycles. And so if you're using a classic-based component, you have stuff like component did mount and all that kind of stuff. Hooks, you kind of have this thing that you could do with use effect that the ergonomics around it aren't all that great. But because we control the life cycle of the component, those don't always work the way that you expect them to. They will work the first time the screen shows, but when you go back to it later, like they won't fire again. So we have our own lifecycle methods that will fire every time you go back to the page. And so that is this, one of them is called IonViewWillEnter. And so this happens every time that the page comes into view. And we'll call this getKids method from that data service that's going to return us back our list of kids. And we'll use setKids to set that into our state. And down here, this is kind of what a basic Ionic page looks like. You got your header section, and then you have a content section. Here in this content, we're going to check to see if the kids array is empty or not. And if it is empty, we're just going to say add some kids. And so if we let that compile real quick and come over here and look, let's turn this back into an iPhone 10. Oh, I need to update the routes to point to that new page. And so this URL will be kids, be the kids list page. And my auto importer, of course, isn't wanting to work when I'm actually doing a demo. Let's see, import kids list page from pages, kids list page. Okay, and then down here, we'll make sure that when they click one of these tab buttons, it's going to go to the kids/kids URL. And instead of the flash icon, we'll use a people icon because kids are people too. And we'll call this kids. All right, now if that is all good, there we go. Title, add some kids. So we'll go back over to the kids list page. We'll replace this title with just kids. And now, let's loop through the kids when we actually pull some back. And so here within this Ion list, let me format this real quick. And I'll do it when I'm done. We'll loop through here. So we're got this kids array. We're going to call map on it to iterate over the kids. And then we're inside of an ion list. And so each item in the ion list is an ion item. And inside the item, we have a label with just some simple HTML to show the kid's name, to show their goal. And then we're using the ion chip component, which is kind of like a notification that you get with a number of whatnot. And okay, so this is going to show up. But right now, my local storage is empty. And so let's add some data into it real quick. And so I got this little snippet. Now just go over into my local storage. And it's called fuzzy data. I know it's probably really small. Now if I refresh over here, I have my one of my 4 kids in it. All right, so let's see what it's going to look like to add another kid into the system. So we'll use instead of going to no screen, we'll use a modal to pop up with it. That will have a form that will add to it. And the first thing that we're going to need is the button. And so here I have the buttons. And so this is up here in the header. We'll use this buttons collection, and inside of here we can throw a button, and the button's just using the icon with the add. And to see what that looks like real quick. Just a little plus button up here. Now these icons are also dynamic, so that, they will change depending if you're on iOS and Android to look appropriate on the operating system that you're on. And then we're going to show a modal. And so in order to show a modal, we need to know if the modal is going to be open or not. So we'll use another piece of state for that. And so we'll have a Boolean called show add kid modal. And down here at the very bottom, we'll add the modal. And so it's just an ion modal component. And so we have the is open property on it. So if it's true, it's going to show the modal. False, it's going to go away. When it dismisses, we're going to set the kids. We're going to go back to the store, pull out a fresh set of kids because the modal might have added a new one. And we'll set the show kid modal to false. And then right now we just have this add kid modal that will show. So when this refreshes, oh, we need to actually make the button up here. Set that state. So we'll say on click, set show kid modal to true. So click it, and now we got the modal that pops up, and you see that it kind of animates up and in. And instead of that, I'll actually show a form. And so the form is going to be in a new component because it's a little more complex. I want to break this apart into smaller components. So I'll add a new file, call it kid, or call it add kid form. And got the whole thing here so you don't have to see me type all this. And so the add kid form, so I'm using TypeScript, and so in TypeScript I can actually strongly type my components and my props that come into the components. And so that's what this interface here is doing. I'm saying I'm going to have an onClose method that is just going to be a method that you don't pass anything into and just returns void. Got a couple pieces of state, the name and the goal. And then here, ion list, which we've already seen, and then we got some form components. And so we got the label for the form. We're using a floating label, and so it actually appears on the form and then will float up when we click on it. And then ion input, which is just a wrapper around input type. So when we change the values, we're setting those state variables. Down here, when we click on the button, if we actually have a value inside a name, we're calling an add kid back into the data service to add the kid, setting the name back to a blank string, and then closing the modal by calling the prop that's passed in. And so down here, we'll replace the text with the actual tag for that, and it's not going to import it for me. Import add kid form from add kid form. What did I call it? Add kid form. No, it is not a default. There we go. Okay, and so now when we click the plus button, we should actually see the form pop up. There we go. So we'll click on name and we'll put in another kid. We'll set his goal to 5, and then we'll put in one of my girls. There are only 2, and so we'll set their goal to be a little bit smaller. All right, so now we got a list of kids here, and now what we're going to do is create that detail screen where we can actually add or take away their warm fuzzies. We don't actually take away their warm fuzzies. That's something my wife really discourages, but the demo's a little bit more compelling with it. All right, so we'll create a new page, and this is called the kid detail page. And I'll add it here, and now we need a new route to go to it, and so we'll go back to the app file and add that route. And so here we got, the same thing. We're doing /tab kids. If this looks a little funky to you, this is actually something internal that we're using here. The actual paths are regexes, I can say it. And this is just actually creating a named variable called tabs with whatever value that they're going into. We use that internally, but I know it does look a little weird. But this is basically saying /kids/ my parameter named ID. And then the kid detail page, which of course it's not going to import it. All right, and I think that is good here. And so we got, when they go, the ID will be their name, and then they'll go to the kid detail page. Let's go and look at the list page again real quick, and you can see that here on this ion item, we're specifying an href, and this href is basically, when they click on the actual item itself, it's going to route them to whatever this URL is. And so we're just saying /kids and their name. And there we go. And so in the actual kid detail page, we'll go over this real quick. Not a whole lot new that we haven't already seen. We got our headers. Actually, one thing that is new here is we got this back button now. And so this back button will take us back to the previous page. And when it's used inside of the same tab, it animates appropriately for the platform that you're on. And then nice thing that does is we have this default href. And so we're able to animate backwards because without them refreshing the app, we know where they came from. But what if they actually go to the page directly or they hit refresh or something like that? That's what this default href does. It says, okay, if they somehow land on the page without any type of history, we know where to send them when they hit that back button. And so if I go and just hit refresh here, I can still hit the back button and go back to the list page. Right now, let's do that circular progress bar. And so this is one of the nice things that I really like about working in the web is that the entire web ecosystem, the entire React ecosystem is open to you as a web developer working inside of Ionic. And so I just went out and searched for React circular progress bar and found a package that worked for me. And so I'll go ahead and add it here real quick. And so it's called circular progress bar. You give it a value, which is a percentage, and then the text that you want it to be inside of the circle. And then we'll import it. And when we import it, we import the progress bar, and then we import the style sheet that goes along with it. So now if we look at it, there we go. We got our progress bar here. So next we'll add the buttons to give and take. Whatever I give, I shall be able to take. All right, so here we got a couple of methods, add fuzzy and a remove fuzzy. Pretty simple what's going on here. We're making sure that they're either not going below 0 or they're not going above their goal when they're hitting the buttons. Updating the kid back into that data store. And then down here, we'll add the buttons. So once again, pretty simple stuff, ion buttons with click methods, icons to show the plus and the minus. Just add all. And so now we got plus and minus. You can see like when we change it, it animates in nicely. That's all, I didn't do that. That's all thanks to the library that I'm using. These buttons, though, they're not really what I'm going for. I want to make them round, a little bit bigger. The icon's a little bit bigger. And so you can use CSS to style it, but since we are using web components, and the web components are kind of protected from the rest of the system, and so we expose portions of those areas inside the web components that you can customize via CSS variables. And so if you're not familiar with CSS variables, if you ever worked with something like React or Sass, it's kind of like that. You can set a variable, but it actually works. It's built into CSS and works inside of CSS. So we'll just add a new file here and call it kid detail page.css. And here it is. And so this is what it looks like to set a CSS variable. It's like a dash and whatever the variable name is. And then anything inside this component is now going to look at that variable and use it where it's needed. And then I need to import the CSS file. So it's included inside of my bundle. Kid detail. What did I call it? Kid detail page.css. And so now I got bigger buttons that are round. You can see I can't go below 0. I go up to 10. I can't go above their goal. So this is showing like how you can use CSS variables to customize this. You kind of do the same thing if you want to completely theme the application to put in your own colors, your own styles or whatnot. There's a theming framework that's available that is all set through custom CSS variables. All right, now last portion of the app, and the part that the kids like the most, I actually showed this to one of my girls this morning, and they were just like, is the celebration, the fireworks that go off, right? And so this is another library that I found out there. I tried a couple of different React ones, and I couldn't get them to work, but I found one that would just use Canvas, and so I wrapped it inside of its own React component. And so let's go ahead and add that real quick. We'll call it fireworks. And And so this is using a library called Fireworks Canvas. And then here, it's pretty straightforward. We are using UseEffect here because this particular one is not an Ionic page, and so it doesn't have the Ionic page lifecycle that I showed you earlier. And so we have to fall back to whatever React provides us, and so we'll do a UseEffect here. And so this basically gets called when the component starts up. This current is a ref back to a div element that's defined below. Setting the options for the components, creating a new fireworks canvas object called start, and then we also have this MP3 file that's in the assets directory, and so we're loading that up and hitting play on it as well. And then this set timeout makes the audio play for 10 seconds, and then it goes away. And inside of our kid detail page, what we'll do to actually show it, here in the add fuzzy method, we'll need a piece of state to say if we're going to show or whatnot. And then the logic is pretty simple. If the amount of fuzzies that they got equals the goal, we're going to set that piece of state to true. And then we'll set a timeout here that's also for 10 seconds. And then after 10 seconds, we'll set that state back to false. And then down here at the bottom, we'll just add that tag. And so we'll say, hey, if show celebration is true, we're going to show fireworks. that imported. There we go. I think that should be good. Let's see, I should have sound on this at least, I would think. So when we hit 10. Yes. All right, so I know you all want to see that again, but I'll tell you what, if you want to see it again, I actually have all this code up on a GitHub repo that I'll link to at the end. But that's pretty much it. So, I mean, like, we're really excited. So to tell you about the state of Ionic React, it's currently sitting in its 8th beta. We're getting ready to do a release candidate of it within the next few weeks. We kind of think that what we have right now in the beta is probably the release candidate for the release candidate. So we're like, hey, if you want to get started checking it out, letting us know, giving us your feedback, it's ready to rock and roll. Put back up the slides. Just a couple of resources here. So we've got a link to our docs, link to our website, you can see my displays. And we'll just show that. And then that demo app is up on my repo. You can go and check out the code for it as well. So yeah, thank you very much. If you want to get in touch with me, you can find me at all the usual places at Eli Lucas, ELY, not ELI. My parents are weird. But yeah, let me know. Hit me up if you want to chat. Any questions? Yeah. We don't have a version of React. And so
Basically, all the power, dynamic responsiveness, where's that living? Like, your actual, the Ionic library that you guys do? Because it happens so fast, that's my thing.
yeah, so we have a library called Ionic Core, and that is our base web components, and that is where most of that magic, where the transitions and animations and all the stuff that determines like what platform you're on and stuff like that. That's where all that kind of stuff lives. The Ionic React library is actually pretty small. Most of it is stuff around the router to make sure that we're keeping the views alive. So when we do go to them, that they're actually still in the DOM somewhere and stuff like that. Yeah. Okay, first question, what do we find most compelling, or what do I find most compelling? I think for that is that I'm able to take my web development skills and use those to write mobile applications. And a bunch of hybrid frameworks have been coming out lately to try to do that. React Native is one of those, but I think like Ionic, like I said, our philosophy is a little different. I can use all of my web skills and all the stuff that's available to me. That, and it's one code base that goes across a bunch of different platforms. So if you think about like the traditional native route, like you actually have to like have iOS developers and Android developers and sometimes desktop developers and web developers and all these different developers to write all these different apps that you have to support. When you're using web technology, you can actually use that same code base to like target all those different platforms. Mm-hmm. So the question is like, what do you need to do to make it a PWA? And so if I come over here into the command line and I say npm run build, which is going to kick off the create React app build script. It's going to throw everything into, I think, the build directory. I can take that build directory. All it is a web application. So you got your index.html file, got all your bundle files, your CSS. You can just take that and deploy it up to a web server and have it work. Now, the one caveat with that is that if you're doing something that tries to access mobile or native SDKs, like if you're running on Capacitor and you have some JavaScript in there to talk to stuff that's happening on the deep down native side, like you have to kind of write if statements to platform detect, hey, am I running in a web browser or am I running on a device? So I don't try to access like the contacts API or geolocation, which, there's a web API available for that, so you don't need to use it and stuff like that. What we recommend is if there's a web API that's available, like in HTML5 or something like that, try to use that and try to take that as far as you can. And then if you really need to dive deep down, then you can go into use Capacitor to call into native code. More questions? Awesome. I do have some Ionic stickers and some other products that we have, stencil stickers and whatnot, capacitor stickers. So if you're interested in stickers like I am, you can come grab some to me after we're done here, and I'll love to chat. Thank you.